This is the first open source model by Google. It's called Gemma and it is apparently outperforming Llama 2, which is one of the best open source models available today and was released by Meta. So over this video, I'm going to be quickly looking at what the model is, and then I'm also going to show you how you can test it locally and also test it on Colab or Kaggle, which is apparently where the model is placed. So Gemma's architecture apparently is similar to the ones that we have seen for Gemini models. Obviously, we haven't seen them because they are not open source. But Google claims that the architecture is similar to that of Gemini models, which are Google's which are Google's most capable large language models. Now, specifically for Gemma, these are lightweight models and are available in two variants, which is 2 billion parameter model and 7 billion parameter model. And they support various frameworks like PyTorch, JAX, TensorFlow, and so on and so forth. These are effectively frameworks or libraries that you will typically use to run open source models. Now, given that these models are lightweight, I'm assuming that there is some direction of mobile usage, but they are right now compatible across all of the devices and they are optimized for NVIDIA GPUs and Google TPUs, obviously. Like I mentioned, Gemma's 7 billion parameter outperforms Meta's Llama 2 7 billion and 13 billion models on a bunch of benchmarks, including math, Python code generation, general knowledge, and common sense reasoning tasks. Let's take a look at these parameters. So I already mentioned all of these. As for the benchmarks, you can see on MMLU, there was a representation of questions in 57 subjects and Gemma scored 64.3 as opposed to this is what Llama 2 scored. And then on the reasoning question, Gemma scored 55.1. Common sense question, and I'm going to show you this is not true because I tested out one question and it didn't give out the correct answer. So it scored 81.2, which is apparently very good score. On math, it did score significantly better than the Llama 2 7 billion parameter, which is surprising, almost 3 times better across both of these math based benchmarks. Even for code, it almost scored like 2 to 3 times better when it comes to the Llama 2 model. Now, all of this you already know because I mentioned. So let's get to how you can start testing Gemma if you're interested in trying out the model and then effectively fine tuning this for your use case in the future. So there's like an entire guide in order to set up Gemma and kind of talk about the environments where you can run Gemma on, right? So the model firstly is available on Kaggle. This is where you would go on Kaggle and download the model card. So on the right side first, you would see view license content. Now, since I've already accepted that I want to access the model and I've given my consent, I can view license content. But for you, there will be something like request model access, right? In which case you will have to provide your consent similar to what you would do on Hugging Face or ChatGPT when you first start using it. Now, once you give your consent, you will see that there are a bunch of details here. It kind of talks about technical, hardware, software details, and so on and so forth. It also talks about the benchmarks that the model went through and talked about these ones earlier as well. So I'm just going to quickly show you these and keep moving on. Then there are the evaluation results. These are again things like how truthful the model is, how bad or good responses being generated, similar to the benchmark we saw. And I'm going to continue moving. So there are limitations, considerations, and so on and so forth. And after you go through all of this, you will find the model here. First, you will find the model variations that are suited for different frameworks, like I mentioned, right? So I said it's Keras, PyTorch, transformers. All of these are technical terms. Effectively, these are all different ways to run the model. So PyTorch implementation will use PyTorch libraries in order to run this, while these are all different libraries or processes in order to run the model itself. For us, this is not something that we'll get into the details, but if you want to run this locally, this is something you should probably keep an eye out for. You can see once you choose any of these libraries, you have an option to download the variation of a model. So you can see there are instructor, fine-tuned model, and 7 billion and 2 billion parameters. Now, if you end up running it in Kaggle, they have a sample code here. And then this is where finally the models are available. So you can see this is Gemma 7 billion parameters for like 17 GB, while there are other config files that you'd also want to download in case you want to run these locally. Now, I'm not going to download 17 GB files, so I'm just going to go to the smaller model, which is 2 billion, and I decided to download the model, but in the meantime, I'll also try this on Colab and Kaggle to see if I can run online to get some early feedback. Once you click there, it will start downloading the model. So if you are someone who wants to run this locally, this is where you download these files and set up your model locally. There are a bunch of sample codes here as well. You can go through and look at some of these codes here, but I'm just going to start a new Kaggle notebook, which is similar to the Colab notebook, and see if I can set up the implementation here. You can see on the right side, it has the option to select the model and install it. But if you are going to go through Kaggle route, just know that this didn't work for me. I'm eventually going to run this on Colab. So I'm just going to quickly show you what happened here. So I kind of set up the model, and then I went on to paste the sample code that we had gotten here. So this was the sample code that we had. I went ahead and added it here. Now, once I started running this, there were a bunch of errors. Now, I don't know if they were model-based errors or they were Kaggle-based errors, but it didn't work for me. Let me fast forward this to show you the errors. You can see this is the first warning, and then eventually I had like a bunch of these warnings, and then post that the model just did not work. Note the reason why this might be happening is because on Kaggle it's running on a CPU, so you can see the 2% consumption right now. This was at 90% when it initially started running, so that's my assumption on why it wasn't working on Kaggle. Now I decided post this didn't work. I decided to go to the GitHub page, and from there I decided to run it on Colab. So there's an option on their GitHub page to click on the Colab icon. Now once you click here, this should open the Google developers page, and then from there you can click on Colab. You will still need your Kaggle access token in order to run this on Colab as well, right? So this is the Kaggle access area where you will effectively have to put your username and access token, and I'm going to show you how you can get that. So you see, once you run that piece of code, you will, oh, by the way, this is the error on Kaggle. So I decided not to run it here, and I decided to continue on Google Colab. All right, so in order to get your access token, just go to settings on Kaggle, click on account and click on create new token. Once you do that, there will be a file that will be downloaded that will have your email or the username and the access token that you need in order to run it on Colab. So once you have both of these details, just put those here in Kaggle. You can see the file was downloaded, and I'm going to go and copy my access token, and I'm going to paste it here. And then once you click login, this should be enough for you to set up the initial connection with the Kaggle, and now you can go on and run rest of the pieces of code, which will take some time because it will install a bunch of libraries and also download the 2 billion model, which is something that we're going to be trying out now. You can note that we're running on a T4 GPU, which is the recommended GPU when you want to run Gemma online. So now once you go through all of these steps, this is where you will be able to enter your prompt. This is again a sample template. There is another one below this. You can see this is here. Both of these are like prompts that you will need in order to just punch in the model and get response. And you can see some of these libraries are now being installed. This will take some time before the installation is complete. So I'm just going to come back once this is done. So the first response is generated. You can see the input was that what is a good place to travel in North Korea. I changed the prompt. And then the model's follow-up was California, and then the user's follow-up was what can I do in California. So this was the initial response that was generated. California offers a wide range of travel options for travelers and so on and so forth, which is relatively straightforward with respect to what other models do as well. Post this, what I'm going to do now that the setup is completed, we'll put in a couple of test prompts for reasoning, math, code, and so on and so forth, and see if it really does as well as the benchmarks say it does, right? So let's continue punching in prompt. I'm just going to change everything to North Korea. By the way, if you don't change the model and user instruction in line with your actual prompt, it's still going to give you the response for California. So I quickly changed that, and it does take some time in order to generate the response, but the response is ready here. So it's kind of talking about the capital city, the provincial capital known as scenic beaches, and so on and so forth. Now this was the first sample of prompt. From the output itself, I'm not surprised, but you can change the output length to 1000 or 100 in order to increase the number of tokens in the final output. Now I don't know if this is the word or token. My assumption is that this is a token, primarily because all the other models use the concept of token as well. So I'm just going to use the exact same prompt that we have here, which is write a poem about an LLM writing a poem, it does take quite some time in order to generate the response. So you can see the output is ready. Let me just copy this and see the amount of words, because the output length we specified was 1000, and apparently the tokens do not seem like they're 1000. So it's basically 96 words, which may be 120 or 30 tokens, which is something that we were definitely not looking for. The next piece of prompt is snake code game Python. Effectively, what I wanted to do is generate code for me that will eventually help me run Python code. In the meantime, let's just quickly take a look at the poem. So you can see the screen flickers, then a surge of words into a purge. So again, I read through the poem and it wasn't as good. Especially if you look at the last part, it says that a digital artist with a view, a poet's lens beyond compare. It does not even rhyme, which is effectively what poems do. And the output that is generated is actually not so good. And I've used Llama before, Llama 2 before, and it does a relatively better generations, to be honest. Now we tried the code itself. So this is the code that was generated by Gemma, and the code looks okay. I mean, it's not as detailed, but initial look says that this is not going to work because it does not have, the instruction for the snake. It does have a game, but it does not seem to have a snake in the game. It says move the snake, but I don't necessarily see the moment for the snake itself. So let's see if we can put this in a code interpreter like Visual Code and actually run this. So I did plug this in my Visual Code, and you can see it's just generated something like this. It's not an actual game. Rather, it seems like an environment for snake to travel. So definitely not something I was looking for. And it did go ahead and generate that piece of code for a 2 billion parameter model. I think it's not too bad. Let me add something else as well. And this is a reasoning question that at this point of time only GPT-4 has done well. So I had 3 cars this morning, sold 2 yesterday. How many cars do I have? So effectively the answer here is still 3, because I had 3 cars this morning. I sold 2 yesterday, which means I still have 3 today. Almost all the models are answered as 1. So if Gemma says I have 3 cars, it's going to blow my mind. So let's see if it's able to figure out the reasoning question well enough for us here. And to my disappointment, it still says I have 1 car left. So again, not very different from Gemini Advanced, which also thought that I had 1 car left. Now, in order to kind of test the creativity side of the things further, I'm going to tell it to generate or turn this into a rap song, like continue from the same point and turn this into a rap song. And this was the output. I am not necessarily happy with it, because this is a verse, then a song. Okay, I did mention it as a verse, but it still should have added exact statement. So I'm going to make that change in the prompt, and I'm going to remove the verse. Let's see if that changes anything. So the output is here, and for some weird reason, there is some weird text at the very start. In this scenario, it says about it. I don't know why that is, right? So you can see there's about it, and then there is the verse to chorus. And again, you can go and read through this. It's not as impressive. It seems like an early version of GPT-3 maybe, but it's not groundbreaking in any way. So it's similar to what other models do as well. I don't really see how it outperformed Llama 2 in the benchmark. And again, given that the evaluation probably would have been done by Google, that does not come as a surprise. So let's try one more question, which is more on the lines of physics. Explain Newton's third law of motion to a 5-year-old. Again, it's not a math question per se, but the goal here is to understand if it can summarize content well enough for us to understand. And this is the output. We have 2 friends. One friend is really strong. Like I said, in the previous generation too, it had some weird text at the start. And in this one too, it has some text. You can see I have 2 friends. One friend is really strong and the other friend is really weak. Okay, and then it starts again. So here's the explanation for a 5-year-old. Newton's third law of motion says, okay, it makes sense. But then again, the generation is not very different. Now let's see if it can generate wrong things. I'm going to change put something like Newton's 8th law of motion, which apparently does not exist. And ideally it should give us a quick note saying that something like this does not exist and not generate anything. So it was able to generate something, and it says, come on, let's go on an adventure. Imagine you're playing in a park and have a big boy truck driving. So apparently it invented 8th law of motion, And I'm just gonna quickly look it up if there's really hip log motion. So I looked it up and there is no. I just confirmed it. I know for a fact that there are three, and I definitely wanted to just see if it can flag wrong answers to us, and it can definitely give wrong answers. It's not very useful that way. And this is the final prompt that we wanted to work on. And yeah, overall, if you ask me, this is, I tried the 2 billion parameter. I did not really try the 7 billion one, so I don't know, maybe that is way better than this is. But yet, I mean, some of the things like reasoning and things like writing poems, all of these are things that all the text to text model have actually done, reached a point where they are good with it. And the fact that this model still struggles with it, it's unfortunate. It's still kind of a breakthrough in the open source space because Google does not really open source a lot of AI models, and this is one of the first ones. So the fact that they are trying and really trying hard this time, I do appreciate what they're doing. So, but that's going to be all for the video. If you guys have any questions, feel free to let me know. Thank you so much, guys, and have a good day.